This model is beginning to get complex, and if we fail to be organized as we go, the feature tree is quickly going to become unwieldy. So before we go any further, let's clean house a little bit. First, we can reorder our new cut extrude features so that they are co-located with their parent revolves in the history tree. So for example, I could take this cut extrude and drag it up. Now, it's only going to let me go back as far as the most recent parent feature, which in this case is the focus ring. So if I drop it right on the focus ring, then now my cut extrude is going to happen right after that focus ring in history. I'll do this again with the circular pattern. And unfortunately, you're not going to be able to do these at once by shift clicking. You'll have to do them one at a time in SOLIDWORKS. So these ones go to the f-stop ring. Now we can also group our features into folders by clicking the top feature of the desired group, shift-clicking the bottom feature, right-clicking on any member of said group, and going down to Add to New Folder in the drop-down menu. This is going to give us a new folder that we can call whatever we want. In this case, I'll call this our aperture ring. Select these, right-click them. We'll call this our focus ring features. And as we add new features, it's going to become increasingly important to make judicious use of named folders to keep our feature tree as short and clutter-free as possible. Trust me, this can be a mess if you are not careful. So now it's time to have some fun. As you have no doubt noticed in the final lens model, text and graphics are mapped all over this lens. So I'm going to let you in on a little secret. Nobody, not no one creates graphics in SOLIDWORKS. Sure, you may have noticed a text tool in the sketcher, but I don't use it, I don't teach it, and I don't recommend it. Instead, I do all of my graphic design elements in Adobe Illustrator, or any vector drawing package that you can export a DXF file from. So first, let's take a brief look at my Illustrator file. I'm including all of the necessary DXF files in the tutorial materials, as well as their corresponding AI files. And I should point out that this is not the official Pentax logo at the top of this camera. It is simply a loose approximation based on the graphics embossed on my particular lens. Now, we don't have time to learn Illustrator here, but there are a few important things you should know before attempting to export your Illustrator into SOLIDWORKS. So, number one, let's make sure that all text objects have been converted to shape items. So, once you've created some text, head up to the menu bar, Type menu, down to Create Outlines. This is going to convert the text to a group of dumb geometry that we can work with. Now, if you have overlapping shapes in your geometry, as I do here with this scripty font, you're going to need to make sure to use the Pathfinder palette to combine them. So I'm going to go up to the Window menu and drop down to Pathfinder, and in the resulting palette, we just need to make sure that with these selected items, I click on Unite. It's going to join those all together so that if we look really closely here, where these two letters intersect, you'll see that they're now one big Boolean shape, all joined together. It's a very important step. You can't have overlapping geometry in a SOLIDWORKS sketch. Now, the third thing is to be aware of the document units in your file. So let's use Menu Bar, View, Rulers, Show Rulers, or hit Control-R on the keyboard, which is what I do, to show our rulers, and then right-click on the resulting ruler at the top of the screen, and you'll see that my document is set to millimeters. It doesn't matter which you use, just make sure that you are aware of it for step 4. Now, finally, step 4, we'll use File, Export, and in the Save as File type, we'll make sure that we have chosen AutoCAD Interchange File, or DXF file. Just save this to my desktop, click Save, and it's going to bring up a DXF/DWG options dialog, and all of this can be ignored with the exception of the artwork scale. This is the only thing that's important. We notice that this document is set to millimeters, so I want for my artwork scale to be 1 millimeter per unit. If these rulers had been set to inches, then I would want to make sure that this scale is set to 1 inch per unit. Okay? And once we do that, you can click OK, and then we'll go back to SOLIDWORKS. Now, with our Illustrator files duly saved, we are back to SOLIDWORKS. So first, let's hit the front plane, go up to the menu bar, Insert, DXF. We'll then navigate to the Assets directory for the tutorial, go down to the Lens Front DXF, and click Open. Now the DXF import wizard is going to pop up. Make sure that you are importing the geometry as a 2D sketch and then click Next. Under the Units of Imported Data, make sure to choose the unit we used when exporting from Illustrator, in this case millimeters. Very important step. Then click Finish. When it asks you if you want to enable the Explode Blocks option, click Yes. Now the imported geometry might not be centered, but that's why we included a circle and center marks. It's very helpful to build datum elements in your geometry to help you in precisely locating your graphics in the model. So select the curves that comprise the large circle and the center marks, and make sure that the For Construction box is checked in the options for those curves. We also need to check the geometry for any errors that might keep our solid features from executing correctly. SOLIDWORKS gives us an amazing tool for this called Repair Sketch. If we go up to the Toolbar Manager in the Sketch Tools, right over here is Repair Sketch, and when we run it, it's going to give us a Repair Sketch dialog, and it's going to search the sketch for any potential problem areas and highlight them for us. Here we can see that the Repair Sketch dialog has discovered one problem, which is a stray line, and in the viewport it has highlighted said problem with a magnifying glass. If we zoom in really close with the mouse wheel, whoa, we can see it. It is a microscopic line. If we click on that line and hit the delete key to delete it, then click on the refresh button in the Repair Sketch dialog, we'll see that no more problems were found. Our sketch is now squeaky clean and ready to go. I can close this dialog. And dealing with complex sketch graphics is much easier if you use a special kind of sketch entity called a block. You can think of a block like a sketch within a sketch, or a way of grouping complex geometry in a sketch. To create a block, box select the imported geometry, then use Menu Bar, Tools, Blocks, Make. Hit the green checkbox or hit Enter to confirm your selection, and notice that a block item has been created as a child of the current sketch. And if we click to deselect the block item, its graphics turn gray despite the fact that we are still editing the sketch. We can now very easily move around the entire group just by dragging. And if we wanted to, we could also rotate and scale the group using the parameters in the Property Manager. Now to precisely locate our block relative to the sketch origin, we can use the regular old sketch constraints. In this case, since we included crosshairs, all we have to do is select the horizontal crosshair, set it to be horizontal with a sketch constraint, then control-click the origin of the sketch, and add a midpoint constraint. That constrains our sketch element to the dead center, and we can exit the sketch and move on. Now let's head up to the Toolbar Manager, Features, Extruded Cut. Make sure we've selected the imported DXF as the input sketch. Now by default, the extruded cut will begin at the plane on which the input sketch sits. It starts at the sketch and cuts in a direction. This can be changed by setting the From property to Offset, and then setting a value for the offset. In this case, let's use 30 millimeters. Now make sure that the direction arrow in the viewport is pointing toward the lens. If it's not, use the arrow button at the top left of direction 1 to flip it so that it is. Rather than cutting some blind distance from the start point, in direction 1 properties, let's choose Offset from Surface, and then select the front face of the focus ring. Set the distance parameter to 0.1 millimeters, and then let's zoom in and take a closer look. Basically, this extruded cut is now coming up to this surface and then being offset by 1/10 of a millimeter. But it looks like the offset is going the wrong direction, i.e. it's offsetting away from the surface. Over here in the direction 1 properties, we can check the reverse offset button, and now we're going to go 1/10 of a millimeter into the surface, which is what we wanted. Now we can click the green checkbox to execute the cut extrude. Now expand the focus ring features folder and drag the cut extrude up into it. Then right-click the cut extrude, choose the Appearances beach ball, and select the feature itself, the cut extrude feature, and set that to a white color. Then click the green checkbox, and voila! We now have white text on our black focus ring.